what is a hypothesis? A hypothesis is a consideration that a given condition or statement might be true. When we are having various alternatives before us, the ANOVA will help us to make the best choice of the alternative. If the p-value is less than or equal to 0.05, then the hypothesis is rejected. If it is greater than 0.05, then the hypothesis will be accepted. Hello everyone, I am Purnima, faculty in the Department of Commerce and Management, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. I welcome you all to this session. In this session 2 of Unit 5, let us understand the importance of ANOVA. So, even though ANOVA involves complex statistical steps, it is a beneficial technique for businesses via use of AI. So, this ANOVA, it involves lot of statistical steps, but it is very much used for AI. What is AI? Artificial intelligence. So, organizations use ANOVA to make decisions about which alternative to choose among many possible options. For example, the ANOVA can help too. So, in order to see that when we are having various alternatives before us, the ANOVA will help us to make the best choice of the alternative. So, compare the yield of 2 different wheat varieties under 3 different fertilizer brands. So, we can just compare the yield of 2 different wheat varieties under 3 different fertilizer brands. So, when there are 3 different fertilizer brands, which brand of the fertilizer is giving us the best yield of wheat that we can choose? Compare the effectiveness of various social media advertisements on the sales of a particular product. So, we can always just measure the effectiveness of the advertisement on the sales of the products. Then third one is compare the effectiveness of different lubricants in different types of vehicles. So, in the different types of vehicles also, we can also see how the lubricants are working. Then the next concept is the chi-square test. Now, what is this chi-square test? A chi-square test symbolically represented as, so this is the symbol for chi-square. It is basically a data analysis on the basis of observations of a random set of variables. So, when there is a random set of variables, so it will do the data analysis on the basis of observations of a random set of variables. Usually, it is a comparison of 2 statistical data sets. This test was introduced by Carl Pearson in 1900 for categorical data analysis and distribution. So, it was mentioned as Pearson's chi-square test. Now, what is a chi-square test? So, it is symbolically, so the symbol for the chi-square is x to the power of square, and it is a data analysis on the basis of observations of random set of variables, and it was introduced by Carl Pearson in the year 1900, and it is essential for categorical data analysis and distribution. Then, the chi-square test is used to estimate how likely the observations that are made would be by considering the assumption of the null hypothesis as true. So, the chi-square test, it will help us to know whether the assumptions of the null hypothesis are true or not. Then, a hypothesis. We should ask ourselves, what is the meaning of hypothesis? A hypothesis is a consideration that a given condition or statement might be true, which we can test afterwards. So, chi-square tests are usually created from a sum of squared falsities or errors over the sample variance. So, what is a hypothesis? A hypothesis is a consideration that a given condition or statement might be true. So, it is a consideration that a given condition or statement might be true, which we can test afterwards. So, we just make a statement based on our observations and then later on we prove it. So, that is what we call as the hypothesis. So, when the researcher is doing research, he comes to a conclusion that the result of the research will be in this manner. So, he will just write it as a statement, and the statement which he says will be the outcome of his result. So, that we call it as the hypothesis, and later on he has to prove that the hypothesis is true or not. So, the chi-square tests are usually created from a sum of squared falsities or errors over the sample variance. So, this chi-square test, it will make use of the sum of the errors over the sample variance, and based on that we can prove the null hypothesis. Then next, in the chi-square test, we have this table of contents. So, what are they? The chi-square distribution, then p-value calculation, properties, formula, test of independence, example, degrees of freedom and p-values table, then solve problems and FAQs. Now, in this, first one is the chi-square distribution. So, when we consider the null speculation is true, the sampling distribution of the test statistic is called as chi-squared distribution. So, the null speculation is true. That means the null hypothesis, so whatever the hypothesis the researcher makes, if it is considered to be true, then what happens is the sampling distribution of the test statistic is called as the chi-square distribution. So, whatever the sampling distribution he has collected, so that will be considered as the chi-square distribution. The chi-square test helps to determine whether there is a notable difference between the normal frequencies and the observed frequencies in one or more classes or categories. It gives the probability of independent variables. So, with the help of the chi-square test, we can notice whether there is a difference between normal frequencies and the observed frequencies in one or more classes or categories. So, it gives the probability of independent variables. The chi-square test is applicable only for categorical data such as men and women falling under the categories of gender, age, height, etc. So, this chi-square test, it is usually used for categories like gender, age, height, etc. Then the next one is finding the p-value. Now, what does p stands for? P stands for probability. To calculate the p-value, the chi-square test is used in statistics. The different values of p indicates the different hypothesis interpretation. So, this p stands for probability, and to calculate the p-value, the chi-square test is used in the statistics, and the different values of p indicate the different hypothesis. So, if the p-value is less than or equal to 0.05, the hypothesis is rejected. When the p-value is greater than 0.05, then the hypothesis is accepted. So, there will be a hypothesis which we call as the null hypothesis, and from the null hypothesis we have to calculate the p-value, and if the p-value is less than or equal to 0.05, then the hypothesis is rejected. If it is greater than 0.05, then the hypothesis will be accepted. Then next one is finding the p-value. So, how do we find the p-value? The probability is all about chance or risk or uncertainty. It is the possibility of the outcome of the sample or the occurrence of an event. So, what is probability? Probability is the uncertainty. So, it does not tell for us surely that this such and such an event will take place. So, it is about risk or uncertainty or the possibility of the outcome of the sample or the occurrence of an event. So, it is uncertain. But when we talk about statistics, it is more about how we handle various data using various different techniques. But when we talk about probability, is something which is very uncertain. But when we talk about statistics, it is very much about the data, which is very, very sure. So it helps to represent complicated data or bulk data in a very easy and understandable way. So it describes the collection, analysis, interpretation, presentation and organization of data. Now we all know what is statistics. Statistics is nothing but collection, classification, summarization and tabulation and analysis of the data. So it all comprises of statistics. The concept of both probability and statistics is related to the chi-square test. Now this chi-square test makes use of both probability and statistics, and with the help of which we will be able to get the answers. Then we also have the p-value. So after finding the p-value, we have to do the data handling, population and sample, variance and standard deviation. The next one is properties. The following are the important properties of the chi-square test. So what are the properties? 2 times the number of degrees of freedom is equal to the variance. 2 times the number of degrees of freedom is equal to variance. So the number of degree of freedom is equal to the mean distribution. The chi-square distribution curve approaches the normal distribution when the degree of freedom increases. So when the chi-square distribution curve approaches the normal distribution when the degree of freedom increases. The next one, the formula, the chi-square test is done to check if there is any difference between the observed value and the expected value. So the chi-square test formula can be written as, see, this is the chi-square equals sigma OI minus EI into 2 whole over EI. Now this is the formula for the chi-square test, where O is the observed value. So this is the observed value and EI is the expected value. So this is the formula for chi-square test. So chi-square equals sigma OI minus EI into 2 divided by EI. Then next, the chi-square test of independence. The chi-square test of independence, also known as the chi-square test of association, which is used to determine the association between the categorical variables. It is considered as a non-parametric test. It is mostly used to test statistical independence. So when we are talking about chi-square test of independence, it helps us to determine whether there is an association between the categorical variables. It is considered as a non-parametric test and mostly used to test the statistical independence. Then the chi-square test of independence is not appropriate when the categorical variables represent pre-test and post-test observations. For this test, the data must meet the following requirements: 2 categorical variables, relatively large sample size, categories of variables 2 or more, independence of observations. Now, we have an example of categorical data here. Let us take the example of a categorical data where there is a society of 1000 residents with 4 neighborhoods P, Q, R and S. A random sample of 650 residents of the society is taken whose occupations are doctors, engineers and teachers. The null hypothesis is that each person's neighborhood of residency is independent of the person's professional division. The data are categorized as. So there is a data relating to 4 neighborhoods. So the neighborhoods are P, Q, R and S, and we are studying the residents of the neighborhoods. So the doctors, engineers and teachers. So we have a total of 90 doctors, 30 engineers, 30 teachers in this P neighborhood. In Q we have 60, 50, 40 and 150, 104, 51, 45, 200, 95, 20, 35, 150. So we have the statistics of the doctors, engineers, teachers residing in these 4 neighborhoods. Now, assume the sample living in neighborhood P, that is 150, to estimate what proportion of the whole 1000 people living in the neighborhood P. So in the same way, we take 349 out of 650 to calculate what ratio of the 1000 are doctors. By the supposition of independence under the hypothesis, we should expect the number of doctors in the neighborhood P is 150 into 349 by 650 is congruent to 80.54. So, by the chi-square test formula for that particular cell in the table, we get observed minus expected into 2 divided by expected value. So that is 90 minus 80.54 into 2 divided by 80.54 is congruent to 1.11. So if we can see here in the table, the total number of doctors is 349, but the total number of professionals is 650. So if you can just see here, so in the same way, we take 349 out of 650 to calculate what ratio of 1000 are doctors. So out of 1000, the number of doctors are 349 out of 650. So total number of professionals are 650. Out of that, 349 are doctors. So here we take this p value as, so observed frequency is 150 into 349 by 650, we get 80.54. So we make use of this 80.54 here. So we find that the answer is 1.11. Some of the exciting facts about the chi-square test. So chi-square statistic can only be used on numbers. We cannot use them on data in terms of percentages, proportions, means or similar statistical contents. Suppose we have 20% of 400 people, we need to convert it to a number that is 80 before running a test statistic. A chi-square test statistic will give us the p-value. The p-value will tell us whether the test results are significant or not. So, the chi-square test, it will give us the p-value, and with the help of p-value, we can just know whether the results are significant or not. So, if the p-value is less than or equal to 0.05, then the hypothesis is accepted. So, if it is greater than 0.05, the hypothesis is rejected. However, to perform a chi-square test and get the p-value, we require 2 pieces of information. So, first one is the degrees of freedom, that's just the number of categories minus 1, and second one, the alpha level. So, you, the researcher, chooses this, and the usual alpha level is 0.05, but you could also have other levels like 0.01 or 0.10. So, in order to perform the chi-square test, we need 2 values. What are they? First one is the degrees of freedom, second one is the alpha value. So, in elementary statistics, we usually get questions along with the degrees of freedom and the alpha level. Thus, we don't usually have to figure out what they are. To get the degrees of freedom, count the categories and subtract 1. So, with this, we come to the end of this session. Hope you have all followed it. Thank you.